shout it out, right? I'm not formal here at all. I will probably forget to repeat your question for the tape, so if I do that, somebody else say, repeat the question, right? And we're not going to go the whole hour and a half. There's probably just about an hour of material here. So we'll have lots of time if you want to just talk about stuff. Take advantage of me. I do actually work at Microsoft, which is probably a surprise to a lot of you. And I have a tendency to be a little bit too honest. So we'll just see how that goes. All right, so what's the problem with wireless? Well, do you all know what WEP stands for? Wired Equivalent Privacy? This is a euphemism, right? Because, how can you secure the air, right? So it's not. WEP is not private at all. And there's plenty of material out there on the web that explains exactly why WEP sucks. And there's just an example URL of where you can go to learn about this. So let's talk a little bit about WEP, how it works, and how it fails to do what the designers were thinking that it might do. WEP uses RC4. So do we all know RC4 here? I think we can safely say that. So there's a shared access key between, I'm going to stand up on the stage before I trip over this wire, between the access point and all of the clients. So this key is used to encrypt the traffic before it gets transmitted, right? Just normal type stuff. Check the integrity of it after it gets transmitted. RC4 is a stream cipher. So you take your key and you XOR it against the plain text and you get your ciphertext. How many of you have ever heard someone say, well, what if we double XORed it to get double encryption? What happens if you double XOR something? You get the something, right? Yeah, OK. And then you go the other direction, take the ciphertext, XOR it with the key, and you get the plain text back out. There are some common attacks against WEP's implementation of RC4 that just pretty much make it useless. Remember that encryption does not mean integrity. Does everybody agree with that? Okay? Encryption is not integrity. If you have a ciphertext and you flip bit 17 from a 1 to a 0, right? Whatever. You're going to flip bit 17 in the plain text too. So this gives us maybe something that we can use to kind of start to force the key back out or derive plain text from a ciphertext if we know the pattern of the bits in the plain text, right? So there's a lot of kinds of attacks that you can do against something like this if you know bit positions. And when you think about an IP stream, if you get a packet that's got an encrypted IP header in it, you know it's going to be at bytes 10 and byte 20, right? You know what that pattern is going to look like. So you can start to just perform some statistical analysis against the traffic and take good guesses at what you think the keys or the plain text might be. So WEP has some defenses against these kinds of attacks. One of them is this thing called an integrity check field. So it's a CRC32 checksum that is added as part of the encrypted payload. But this checksum is not, the checksum is not keyed. Okay, there's no integrity check against the checksum itself. And in a bit, we're going to see why that's a problem. So the IC field itself, it can be subject to bit flipping attacks, right? So we can now start to maybe force this thing out. So we say, OK, that's not enough. Let's add an initialization vector. So we have this key. We're going to make it a little bit stronger by adding an IV to it. The problem is that it isn't big enough. OK? Say an access point is sending out 1,500 byte packets at 11 megabits per second, which is, what an access point does, right? Because it's only a 24-bit field, you can exhaust the entire key space in 5 hours here. So that's like what, between breakfast and lunch? It's not even a challenging thing to do. If the packets are smaller, if your network has a low MTU somewhere, these are going to be what, maybe 576 byte packets now instead of 1,500. So not only that, but some wireless interface cards don't implement the IV right. They'll set it to 0 every time the card is initialized, or when you wander from access point to access point. A lot of cards don't randomly increment these things. It's just incremented by 1. Now, what was the problem with TCP initially with sequence numbers, right? Not being predictable, increment by 1. We can very easily predict packets, right? Same issue here. Doesn't anybody learn from history? But the biggest thing that I think is really weird is that 802.11 does not even mandate that using an IV is a requirement. So a lot of the cheap home RF type stuff, well, no, that was actually a standard, wasn't it? Home wireless gear that's targeted to home users doesn't use this. So what are some other kinds of attacks that we can perform? Well, since the IV is small and it's got no way to protect against reuse from that thing, we just opened up RC4 to all kinds of it's got all kinds of vulnerabilities that can be very easily exploited. Some of this, it may not make sense if you don't really understand cryptography and math, and I'll admit that that's something I'm still trying to pick up onto. How does the algorithm really work? I think that's kind of a fascinating thing. But a lot of these attack classes are documented in that paper that was on the first slide that pointed to problems with WEP. A couple other things. All of these classes of attacks, by the way, we're going to be fixing with the security protocols I'm going to explain in a little bit. It's pretty easy with 24 gigabytes of storage space to construct a dictionary of all possible initialization vectors and key streams. So once you've captured this data, and you can do this passively, right? You've all read about this kind of thing, sitting in a parking lot with a Pringles can, just grabbing data. 24 gig is not a lot of data that comes from a large organization that has 100 buildings with wireless access points all over the place that might be sitting in a lush pine tree campus on the other side of the lake. So there's a lot of problems here. I keep saying that just because we got to fix this. So last slide here, for those of you who are interested in problems, go to some of these URLs and download some of these attack tools. They're pretty cool. So what do we need to do to get around the problem of the WEP suckage here? Fundamentally, we got to do what's in the green, is that we want to generate new keys periodically, not just the initialization vector. It doesn't provide enough of a key space by just generating new IVs. Another thing that would be nice to do is to have separate keys for each client. How does it work now? You take this WEP key and you put it in the access point, and you put it in every client that's talking to the access point, right? And as we talked about yesterday with IPsec and shared secrets, what's the problem with a shared secret? They don't remain secret for very long. Some other problems that we want to solve. There's no concept in WEP of mutual authentication. The access point doesn't really know who I am. I'm just possessing this key, right? And I'm certainly not doing anything to authenticate the access point or the authenticator, the database behind the access point that has the list of allowed users. So it would be nice if there was a way in the authentication protocol for me to authenticate the server side, just like we do with SSL. I'm authenticating the server side. It's extremely easy to force another client off the LAN because 802.11 association and disassociation messages are not protected. So you can just send a disassociation message to a client, and it goes off the LAN. And then finally, we don't have a way with WEP to stop people from gathering useful information when they monitor. Right? Of course, you can always grab it. It's always going to be in the air. But what can we do to maybe make it really hard or even impossible for someone to make sense out of what they have captured with their Pringles can antenna? 802.1x is the is the answer right now. Okay? There's a lot of work going on to have an even better thing that's maybe more specifically suited for wireless. But it turns out that this port-based access control mechanism defined by the IEEE called 802.1x works really, really well for wireless. Originally, it was intended for wired LAN connections. You know, you plug your LAN cable into the socket. If you don't do 802.1x, you don't talk to the switch. Same thing. We don't do 802.1x, we don't talk to the access point. No special requirements on your wireless interface card. It'll pretty much work with any wireless interface card. But you do need 802.1x support in the access point. So your $89 Netgear access point doesn't do it, or at least mine $89 Netgear access point doesn't do it. So what do I do at home? I change my WEP key about every week or so. You can, 802.1x allows you to specify a variety of authentication methods inside this thing called EAP. We're going to delve into EAP a little bit later. And you don't need to manage these keys anymore. One really cool feature of this is that key generation and distribution is suddenly taken out of your life and handed to an electronic device that can do it much better than you can. Is 802.1x, yeah, question?
Just going back to WEP for a second, if you crack the WEP key,
right.
would it be a realistic attack to inject your own access point with the same name and the same?
Aha! So the question is, we've cracked a WEP key, okay? Is it possible by possessing this key to then set up a rogue access point? Yes, that is an entirely possible scenario if you don't have 802.1x, because the client is not authenticating the access point or the authentication server, right? So it won't know. Yeah.
So you could drive up in a van with your own access point, which is really loud.
Uh-huh.
Your own web server look like the client's internal web server, your own DNS, and then start to capture full firewalls.
Yeah. Yeah. I've not seen anything like that actually happen, but you know, standing up here in front of a crowd of 90 people, I'm not imagining anything right away that would say you can't do that, right? So I mean, it sounds like a legitimate attack. You know, some access points let you set up, you know, configure MAC access list, right? You know, I'm only going to allow these wireless MAC addresses. Well, you know, MAC addresses are spoofable, but how many of you would like, for the rest of your life, to do nothing but manage the MAC access table in your wireless access points around your corporation? This is the reason why we have DHCP now, right? Because managing IP addresses was bad. So yeah, your scenario is perfectly plausible, but with the 802.1x and the EAP, TLS, and PEEP, it goes away.
No, I'm just saying.
Oh. Okay. Oh, you want to do that. You want to manage MAC? Okay, so this gentleman is for hire. He will manage your IP address list and your MAC address list for you. So we do solve some things with 802.1x. Okay? We can't get the key now, right? Because we have a ton of different keys. We are eliminating the conditions under which someone can establish a rogue access point. And actually, that's really not so much the AP. The AP is a transparent device. It's the authorization server behind the access point that we can't bring a rogue radius server up, for example. So we remove the man-in-the-middle attack. There was a paper that came out some number of months ago claiming that 802.1x was insecure and that it did not prevent man-in-the-middle attacks. There is a flaw in the paper, because the paper is assuming that the client is not authenticating the AP or the authorization server. We do this. It is a requirement of our implementation of 802.1x that mutual authentication occur. And when that happens, which also happens with Cisco Leap, by the way, when you have mutual authentication, the man-in-the-middle attack, the traditional man-in-the-middle attack over 802.11 is not possible. We're solving the unauthorized access problem because we are going to be authenticating both users and computers. You'll see that in a little bit. But we haven't solved the problem of just injecting a disassociation packet onto the network and kicking a client off the LAN. right? Because remember, the association, disassociation messages are not encrypted. They're not authenticated. So you could still kick somebody off the network. The actual replacement for WEP will take care of that problem. So let's clarify a little bit of terminology. This is probably not an issue for the people here in this room, but sometimes it is. So I throw this slide in. 802.11 is the specification for over-the-air wireless networks. All right? 802.1x is a physical layer independent specification for port-based access control. Makes a lot of sense to combine them. There is no such thing as 802.11x. I've seen people use this phrase. There is no such thing. And I've also seen people say, oh, well, I'm not using 802.11. I'm using 802.1x instead. OK, so what's your air interface, right? Yeah, they're still using 802.11. 802.11i is the forthcoming replacement for WEP. So 802.11i kind of combines some cool stuff in 1x, along with an interim replacement for WEP, which I'm right now forgetting what it was called. But this is what the IEEE is working on as the actual official replacement. So how does 802.1x over 802.11 work? So there's 3 elements here. So here's some terminology for you. The supplicant is the client. That's the laptop with the WIC, right? The authenticator is the access point, and the authentication server is Radius. So before we can do anything that has to do with 802.1x, we have to perform the 802.11 association. So we're actually associating the 802.11 completely before we're doing any authentication or authorization. Now, you might immediately start to think, oh, that's bad, I don't want to do that. Well, in a couple of slides, I'll show you how communications are being blocked from the supplicant when this happens. Then we start using EAP, Extended Authentication Protocol over LAN. So EAP over LAN, the EAP over LAN start message goes from the client to the authenticator. The authenticator sends a notice back. It says, hey, tell me who you are. The supplicant sends a response to the authenticator. The authenticator then sticks that inside Radius and sends that over to the Radius server. The Radius server then sends a challenge back, which the authenticator sends to the supplicant as an EAP request. The supplicant sends a set of credentials back. So this could be a variety of things, right? This all depends on what particular authentication method you've decided to allow inside EAP. EAP is a framework for carrying authentication messages back and forth. It is not an authentication protocol itself. So the credentials are coming back. The authenticator then sticks those inside Radius, sends them to the Radius server. The Radius server sends back an access accept or reject if the credentials are bad. Authenticator then sends a success to the supplicant. And then finally, the authenticator sends the WEP key to the client. So here's how we're getting this per client key requirement solved, right? We don't give the key back to the client until authentication has succeeded. So yes, while we have an 802.11 association done, we don't have an 802.1x association done until the key comes back. And only after the key comes back can the supplicant pass through the authenticator, the access point, and get to the network behind. So remember, we need to talk to the AP, right? We've got to get an IP address so we can do this. Therefore, you are configuring your access points for open authentication. You're not going to use shared authentication anymore, where you're programming a key into the AP. Well, you still do put a key in there, but it's not for what you think it's for. Access beyond the access point is prohibited until the authentication succeeds, like you saw at the very bottom of the previous slide. Once the key comes through, then access beyond the AP is allowed. the security conversation is between the supplicant and the Radius server. Remember that. Okay? The wireless NIC and the access point are just, they're purely pass-through devices here. So before authentication occurs, the authenticator, all access points are going to have two virtual ports. Now, this is a single physical Ethernet port on the thing, okay? But it's treated by the software as two virtual ports. The controlled port is the one that allows traffic from clients to get to the LAN behind the AP. The uncontrolled port is what the access point itself uses when it needs to talk to the Radius server. So before a client has authenticated, the state of the authenticator is like this. Traffic from the supplicant cannot pass through the AP, but traffic from the AP itself is allowed to go through. Otherwise, how could the access point talk to the Radius server? Once authentication succeeds, then, the controlled port transitions to a closed state so that traffic from the client can pass through to the LAN. Some people like state machines, so that is the purpose of this slide here. It's just another way of thinking about the same process. So the initial state of a wireless client is that 802.11 is unauthenticated and unassociated. So this notion of these are the kinds of wireless frames that the client can use to talk to any device, right? Only class 1 frames are allowed in or out here. Once we do a successful open authentication, which for 802.11 is simply, hi, I'm here, and the AP says, OK, I see you. 802.11 has authenticated, but we're still not associated yet, right? So now we can have class 1 and class 2 frames coming from the client. Once we successfully associate or reassociate, if we've roamed to some other AP somewhere, we are now 802.11 authenticated, and we are associated, but we're still not actually doing any traffic yet because we haven't done anything with 802.1x yet. So class 1, 2, and 3 frames are allowed in now. Once we have performed a successful 802.1x authentication, we're at the end state. 802.11 authenticated and associated, and 802.1x authenticated. We're done. So we've disconnected the wireless NIC, or someone sent us a non-nice disassociate message. So the client sends an EAP over LAN log-off message to the authenticator. A disassociation notification then goes to 2 different states at the same time. So we're back to state number 1. So that's how many of you have seen TCP state machines? Okay, a couple of you. So you'll understand this kind of diagram then. And then finally, to move from state 2 to state 1, we issue a deauthentication to the AP. Now about the keys. One of the requirements, remember, was that we wanted per user or per station keys. The client and the Radius server generate per user session web keys. These keys themselves are never sent over the air. The Radius server sends the key to the access point, which is encrypted with the Radius shared secret, right? Now, the access point has a global WEP key. You still program a WEP key in the access point when you're using 802.1x. And this is used when the access point is authenticating itself to the client. And it's sent in the EAP over WAN key message, and that is encrypted with the session key that the Radius server generated. Session keys will get regenerated automatically under 2 different conditions. When the key time is exceeded, and our default is 60 minutes with our Radius server, that's configurable, or if the client roams to a new access point. So if you're on this side of the building over here and you came over here, say they had 802.1x set up at Black Hat, then you'd get a new key because you're going to be on a new AP over here. Any questions on any of this so far before we get into some of the meat of EAP itself? Yeah, go ahead.
You said that the
You program a WEP key in the AP, yes.
You have to now go to every one of the wireless cards and put that web key?
Nope, nope. This is something that 802.1x does, right? Okay. That key that the access point has is used when the access point, when the Radius server, right, wants to authenticate itself to the client. That happens first. Then after the client says, OK, I believe you, I trust that you're a good access point and you're a good Radius server, then the client authenticates itself to the server, right? So the client doesn't have a key yet. The server uses this key to authenticate itself to the client. The client then, when it wants to authenticate to the server, will, after that authentication succeeds, the Radius server generates a per station key. This is the key that then gets sent to the client that's used for encrypting all of the traffic afterward. Yeah, that was kind of a difficult thing for me to wrap my brain around initially, too. So it's now the key in the AP is performing a different function than it did before. Yeah. OK, the question was the user authentication credentials, how are they encrypted? I'm actually going to talk about that in a little bit. OK, so we'll get there. Was that your question? Yeah. Yeah, we'll talk about how the user credentials themselves are protected in a little bit. So let's talk about EAP a bit more so that you can understand credential protection. You need to understand what EAP is. EAP is a extensible authentication protocol, and it's just a framework for building an authentication mechanism, right? EAP itself has no security built in. It's just a way that two peers can specify a particular authentication protocol that they both want to use. So, if I've got a suite of protocols and you have a suite of protocols, we're going to offer, right? I can do A and B. What can you do? And oh, you can do B and C. All right, so we'll use B, right? For mutual authentication, you could put a lot of authentication methods inside EAP, but one of our requirements is mutual authentication. So that limits the number of methods that we can select from for wireless. And this is even more. For wireless, we don't even use this many. But mutual authentication, we use TLS, right, certificates. We can use IKE. Could conceivably use Kerberos if you wanted to, although I've never seen an EAP Kerberos implementation. Or there's this interesting thing called PEAP, protected EAP. You'll see why that becomes important in just a minute. In Windows, we specifically disallow EAP MD5. MD5 is an allowed authentication method for EAP for VPNs. We don't even let you pick that when you're selecting for wireless, because MD5 lacks the capabilities to create an encrypted session between the supplicant and the authenticator. It also doesn't give us the ability to do mutual authentication. And it would open up the system to man-in-the-middle attacks. And that's one of the things that we're trying to eliminate here. So in Windows XP, in the initial release of the software, the only EAP method we had for wireless was EAP TLS, which required certificates. We thought, yeah, this is going to be great. The world is ready to move to certs, right? Because we all know that passwords, what? Say it with me, suck. Well, guess what? A lot of people still have to use passwords for things. So in Service Pack 1, we've added support for another EAP method called protected EAP that lets us put credentials in a protected channel between the client and the authenticator. And this has become a really big deal for a lot of my customers lately anyway, because they're just not ready to move to a PKI yet. But they want to do wireless, and they don't like web. So if you think of EAP as being a framework that lets you specify an authentication method inside of it, PEEP is kind of a wrapper. It's sort of an authentication method that lets you then specify more authentication methods inside that don't directly talk to EAP. You saw we had EAP TLS, right? If you wanted to do Kerberos over EAP, you would have to write some kind of an interface called EAP Kerberos, for example. The point of protected EAP is that you don't need to write an interface between your favorite authentication protocol and EAP now. You can just stick it inside PEEP, and it will get used. For wireless, our protected EAP implementation allows MS-CHAP v2, so this is passwords, right? And then we're also actually allowing you to do TLS inside PEEP as well, because it's just an easy thing to do. That way you don't have to run two authentication methods at the same time. You can just run PEEP, and then you can use either passwords or certificates. It is also possible, but it's not something that we've tested yet, so we don't support it, is the idea of running Secure ID inside protected EAP. So I kind of alluded to this a little bit, is that EAP will run over any media layer. Hey, it's a PowerPoint, man. It's got to have animations, right? The method layer then lays on top of EAP, and then if you're using protected EAP, you can pick from those additional methods that run inside it. But really, you could run any authentication methods you want over protected EAP, except for, of course, MD5, which we specifically disallow for the reasons I mentioned earlier. So now that you understand problems with WEP, you understand 802.1x, and you understand EAP and protected EAP, I just want to check, any more questions before we go on to how this actually works on Windows? All right. So let's lay the requirements out again. This is what we need. Mutual device authentication, right? We want the workstation and the authentication server to authenticate themselves to each other. This means we don't have to worry about rogue access points anymore, prevents man-in-the-middle attacks, and it ensures that we're transferring the key to the correct entity. What if we weren't authenticating the client? And there's no way to guarantee that third bullet, right? We don't know we're sending the key to the right person. What if we don't authenticate the server? Then the client doesn't know that it's getting the key that it wants, right? You really need this. We are actually going to be performing user authentication too. So that helps us get past the unauthorized access problem. A couple more security requirements is that we want these keys to be unique for each workstation, and we want them to get regenerated periodically. And we want to be able to stop this packet or disassociation spoofing. You'll see in the end we can't do that last one yet. So I'm just curious here, and we've all known each other for the last 4 days now, so it's OK if there are things you don't know. But how many of you already understand that when a domain member logs on, there's actually two logons that occur? The computer and the user, right? A domain computer has a computer account, a machine account. And you don't actually see these accounts unless you go look at them in AD. You certainly don't see it on the client, right? Password maintenance happens automatically. When you turn the machine on, one of the things that happens under the covers, oh, by the way, you can actually, you can make a group policy setting so you can watch all this stuff occur. So just start up an MMC, right? And let's see, where is it? I think this is kind of a fascinating thing. I'll show you. Group policy, local machine. Of course, this is one of these things that you do at the very last minute and you forget where it is, right? OK, so it's under local computer policy, computer configuration, administrative templates, system, verbose versus normal status messages. So change that from not defined to enabled, and when you have the little dialogue that's telling you what your computer is doing as it starts, it gives you a lot more information, right? So before you see the box that says hit Control-Alt-Del to log on, the computer has already logged on to the domain. That's how we apply computer policies, startup scripts, these kinds of things that run in the context of the local computer. It looks just like a regular Windows logon. There's nothing different with a computer logon. So it can be a user ID, password, domain, credential, right, or it can be a certificate. Maybe we can take advantage of this with wireless. And that's actually what we're doing. We want to make a wireless logon look just like a wired logon. And our implementation of 802.1x will do that. So in our PEEP, the very first phase is a machine logon. So what happens? Well, we get that, the things we saw before, right? The 802.11 association, authenticate the authentication server, authenticate the computer, transition that port for the machine account from open to closed. So what that means is that only things that occur in context of the machine account can communicate over the AP to the domain controller in the back. You need that to happen, right, to process logon scripts and computer policies. Stuff that happens in the context of any user account won't be able to go through that because the port is still open for the user. So the second phase then is the user logon, where we authenticate the user, and then again we sort of transition that port a second time, right, so that now the user account has access over the network. Understand here, even if you're using protected EAP with passwords, there still is TLS going on. The authentication server, the Radius server, must have a certificate. That's how it proves its authenticity to the client. And that's done over TLS. So when the client receives that certificate, it will verify the name and the date, right? So don't pre-issue your certs, right? If the cert is not valid until tomorrow, it's going to die. And it also will validate the chain, make sure that it comes from a CA that it can chain itself up to. So what have we satisfied so far with just these 3 steps in that first phase of the machine logon? Well, we have completed 1/2 of the mutual authentication. That is, the client now trusts the authentication server. And we've satisfied the no rogue access point requirement, right? This client will not talk to an AP that cannot talk to an authentication server. So you're thinking, well, but how is that secure? Well, remember that APs talk over Radius to the authentication server, right? So the AP has the Radius. Well, this is the only time we can't get around these notion of shared secrets, right? The AP has a Radius secret, and the Radius server then has the AP configured as a client in its Radius configuration. So if you wanted to bring up a rogue authentication mechanism, you'd have to bring up not only a rogue AP, but you'd have to bring up your own Radius server too. And since the Radius server is trying to hand a certificate to the client, you'd have to put a valid cert on the box. And there's enough administrative procedures in place, right, that can generally prevent somebody from bringing up a Radius server in your network with a certificate that's going to authenticate itself to clients. But that's all we've done so far. So more of the first phase. I'm getting wrapped up in this thing. The supplicant sends the machine credentials over this TLS channel to the server. So you've got that TLS channel set up, right? When this authentication server authenticated itself to me. So over this same channel, I'm going to send my machine credentials, or my machine certificate, if that's what we've decided to use. The authenticator checks the validity by doing the normal Radius kind of thing, right? The authentication server is going to go talk to the directory. If it's valid, the Radius server generates the WEP key. The authenticator delivers the key to the supplicant, and that's over this TLS channel, right? So that's how we're protecting the delivery of that key. And then we transition that port from open to closed for things in the context of the machine account only. And then the computer logs onto the domain, and you see all the messages that say, processing computer logon scripts or whatever. And you finally get the box that allows you to hit Control-Alt-Del to log the user on. So when we complete the machine logon, we've got the other half of mutual authentication done, and we've provided a unique web key to the client. Second phase is authenticating the user. So this is very much like the first phase, except that, well, the parts of it we're not doing, right? We don't have to have the authentication server re-authenticate itself to the client here, because we've done that once already. So the second phase is really all about just the user themselves authenticating to the environment. And you can see the ports there, or the steps there. Once the authentication succeeds, now the user is allowed to talk over the controlled port, and you're completely logged on to the domain. So we finally we hit the last of the requirements there that we can solve with the technology, that is authenticating the user. But we can't take care of this disassociation spoofing with 802.1x, and it's because of the way 802.11 is designed. So now I need to say that some people say, well, what do I need to worry about my machine account for in a wireless network? I had a customer who deployed Leap all over their network, and then they ran into a problem when their password started to expire. Leap works really well for the second phase. It does user authentication just great. But Leap doesn't kick into play until after the machine has already logged onto the domain. But if we're not totally associated, the machine never logs onto the domain. It's just using a cached credential. And when user accounts expire, if the machine can't log on, you're going to have a problem. You can't change your passwords. This was a problem the customer was having. When a password expired, the user couldn't change their password over wireless. They would have to go to a wired workstation to do this. So you want to have a domain logon occur, right? It happens over LAN, so it needs to happen over wireless too. And there's all the normal reasons why, right? And having the machine logon occur is what allows us to be able to change our passwords over wireless, right? Because the WIC is associated and it's transitioned, so we get that notification that, hey, the password has expired, right? And the machine account logon phase allows those password expiration notices and the changes to occur. So why passwords? With all of this talk about certificates being the only good way to authenticate people anymore, not everyone's ready for a PKI yet. How many of you actually have in production a PKI? Okay, leave your hands up. How many of you put it in place because an application needed it? So the rest of you who put your hands down just put it in place because it was cool? No? Why did you? For email signing. Okay, so I would say that's an application need. Yeah. Every PKI deployment that I've ever been involved in that was put up without an actual business need for it has failed, right? They just don't work. Not only that, but sometimes there are technical limitations that prevent people from being able to use certificates for one reason or another. One of my customers who deployed this, it turned out that in their analysis of the business requirements, when they thought that EAP-TLS was going to be their answer, certs, they failed to remember that they had several hundred users who would roam from computer to computer. Can you imagine what managing machine certificates or user certificates is going to be like in that scenario? They weren't ready to do smart cards yet. So now, let's say it's 600 users, 600 other computers, but there's no one-to-one relationship between a person and a machine. So now every one of these machines has to have, what, 1,200 certificates on it. So there are instances where passwords are still, they make a lot of sense, even though they're not any good anymore. I really think that smart cards are actually the answer to this kind of thing. And my customer who is doing PEEP now is actually planning for a smart card deployment in about 6 months. And I tell you, the best way to do that is to do what we're doing at Microsoft, is give everybody a new employee badge and put your smart card on it. Just make that your smart card, right? Because what's the problem with most cards that you carry around in your wallet? Okay, well, I'll get to that, right? So let's talk about sociological issues here for a minute. Next time you're in New York and you're riding the subway, don't be a blind New Yorker and swipe your thing and go on. Stand there for 5 minutes and watch people mess around trying to figure out how to put their card in the reader, in the gate. There's 4 ways you can put a card in a card reader, right? So, that right there is sometimes a barrier for some people. Another barrier is these things have no stored value. This card is generally, let's say it was just a smart card and not my Microsoft employee badge. It's got no stored value, right? It's not like a credit card or a debit card or something, so I care less about it. So I'm probably going to lose it. Well, one way you fix that is you do what the Black Hat people did. Lose your badge, $500. Can you expense something like that back home, by the way? That would probably be a really hard thing to hide in an expense report, I think. But most people don't forget their employee badges when they go to work, because, at least for us, this is the key to unlock the doors, right? I can't get around on campus very much without this thing. So since I'm already used to having to carry this, and you probably are all already used to having to carry your employee IDs, when you're going to do your smart card rollouts in your organizations, replace your employee badges with combined employee badge smart cards. You're already used to carrying these things around, right? Now, there has been thought at Microsoft about having a financial penalty for people who lose these things. That hasn't happened yet, right? Because there's a PIN to unlock this thing. So, if you were to find it, it probably wouldn't do you very much good. But I still think that there should be, right? I personally believe that if I lose this, I should have to pay $100 or something. That sort of imputes a stored value onto the thing, doesn't it? How about biometrics? Use your finger, right? Okay, so I'm going to cut your finger off, right? I mean, you've all heard these stories, right? I love biometrics because they're gross, right? I'm going to cut your finger off and put on the smart card reader. Oh, wait a minute, that's a smart card. Fingerprint reader. That's a smarter fingerprint reader. It needs heat. Okay, right? Oh no, it needs a pulse. Can't get around that one. Okay, pump water through it. All right. I'm going to pump up your finger here. And then you can carry that farther, right? Well, if it's a retina scanner, eyes are easy to remove. Biometrics are kind of interesting, but you cut your finger and you have a scar for 2 weeks, right? Or you get a wart or something, right, that changes the way your fingerprint looks. And I don't know. I think that I don't think the technology is there yet. I like the smart cards because they work, right? And they're not that expensive. It's cheaper than something like Secure ID, right? A card reader for a PC card reader for a laptop is what, $20, and the card is $10. I mean, that's pretty inexpensive, and they don't have batteries; they don't wear out. Yeah, you're stuck with a password to unlock it, right? So that's a PIN to unlock the card, but the goal is, right, the card and the computer are stored separately when not in use. So you don't carry the card in your wallet with the PIN handily written on the back of it, Okay, no, you carry your card in your wallet, right? You don't carry the card in the briefcase that you put the computer in. Now see, that's a configurable thing in Windows. My card has to be in only during the VPN logon phase. Once I'm logged on, I can pull it out. We don't actually use smart cards for domain authentication yet, although that's probably going to come soon. And you can then indicate in your group policy whether the card must be present at all times or not, right? So you could set it up so that if someone pulls their card out, the workstation locks. I like that a lot. Yeah. So the point is, somebody will normally leave that card in all day, right, with the computer screen that never locks. Well, group policy will allow us to say, lock the desktop after X number of minutes of unuse. But she still has to take the card with her when she goes home. Or I should say, he or she still has to take the card with, because it's the only way to open the building when they come back the next day, right? Or to get out of the place, right? Yeah, so, yeah, right. Come to my sessions and get a little sociology each and every time. So remaining vulnerabilities here. Yeah, now, we haven't solved everything, right? We're pretty close, but, it's like radars versus radar detectors. It's always going to be this kind of thing going on, who's in front of whom. It's still possible to spoof 802.11 packets. Now, they're not going to do you a whole lot of good, other than kind of confuse the access point, maybe, or confuse the wireless client. But you can still disassociate somebody. As a simple addition to 802.1x will solve both of these problems, but you're actually not going to see that appear until 802.11i. And that's the notion. Actually, I think I have a slide on it, so I'll just wait for a second. What are these bit flipping attacks like? Well, we don't have any per packet authentication going on here. And 802.11x doesn't add that, right? Unlike IPsec, where every packet is authenticated, we don't have a per packet authentication mechanism going on here. And since the IC is not keyed, you can flip bits in a WEC packet and recompute the IC and make that appear to be a valid packet. So if you want to spoof a packet, or if you want to replay one, right, what do? You learn the IV first, which is really easy with all these attack tools that are out there right now. Flip some bits. The access point is going to accept it. The layer 3 device behind the access point will reject this, but it sends a predictable response, right? So, which then gets what? Encrypted, right, on its way back to the wireless client. And if we do this enough times, we can build a database of what these responses are like and derive the key. So you want to be sure that you've configured Radius to generate keys at an interval that allows someone, or that prevents someone from getting enough, information to derive the key, right? That's why we've set the default at 60 minutes now. Both of my customers who've deployed this have actually changed that to 30. Just kind of a comfort thing. I don't know what number to tell you to pick, right? I could stand up here and do some numeric proctology for you, but I don't think that would be, a pleasant experience for any of us. So pick a number somewhere between 1 and 60, whatever you're comfortable with. But just remember that key generation is not an instantaneous process. It takes a couple seconds. So if you tell the thing to generate a new key every minute, you're going to have a lot of unhappy people. And we've talked about this a lot. So what is it? This is a great way to denial of service a wireless user. Just send them one of these, right? You know what my favorite denial of service attack is? It's enabled by something that probably a lot of you have on your network. Password lockout policies. How many of you are using account lockout policies on your networks today? All right. What's your threshold? What do you have it set? 3? You don't? 3, OK. How many of you have really high numbers, like 50? OK. So after the 3 minutes is over, does it automatically unlock, or does it require an administrator? How many of you have manual unlocking only? OK. So you have someone whose job it is to do nothing but reset passwords? Yeah? OK. Help desk. You know, I hate this thing, and I wish we'd just get it out of the product, because account lockout policies don't solve any real problem, but they create great denial of service opportunities for an attacker against your network, right? You know, I'm not all that interested in breaking into anybody's network because, you know, personally, I've got more important things to do than to read your email. But boy, it sure would be a lot of fun just, you know, find out your user space and just start logging in a bunch of people with garbage passwords so when they come in on Monday morning, they can't get access, right? You know, I don't think account lockout policies solve anything when you have them. Or if you're really paranoid, set it to a high number like 50. Because if you're anything like me, what happens? You're halfway around the world, you got to give a presentation in 30 minutes, maybe you had a little bit too much to drink, and you need to log back onto the network to upload it or to get a more recent version of your PowerPoint. Well, what? You're clumsy, right? What's that? Yeah, the caps lock key is on, right? Okay. 2 tries. 3rd try, boom, it's wrong, you get locked out, but what? You're on the other side of the world. So where your account database is, you know, slumber is the order of the hour, right? So who's going to, and you're stuck. I mean, you know, this is real world stuff, right? You know, I know a salesperson who lost a sale because he fat-fingered his password 3 times and couldn't get some data. So, you know, think about it. Set these things really high to like 50. So the only time it gets triggered is with a DOS attack and not somebody fat-fingering their password because they had too much to drink. I'll get off that box now. So how do we solve these 2 problems? You need to key this IC. If the IC were keyed, then, and we included that in every packet, we'd have, well, what would it do? It would perform this per packet authentication, right? So we couldn't do the bit flipping attacks. Could probably still maybe do these. I'd have to think about that one from, no, it'll get rid of that one too. What is a good example of keying the IC? Well, this is actually something that Cisco does in Leap. They have keyed ICs, and they derive the key from some seed value, which of course is, you know, not revealed to the public, source and destination MACs, and the actual payload itself. So of course, any change to these derivation values will alter the IC, and we know now that the packet has been modified. So what do you need to do to build 802.1x with EAP or protected EAP? You need Windows XP Service Pack 1 on your client. On the server, you need Windows Server 2003 IAS. This is not ISA, it's IAS. Don't you love this letter reuse in the acronyms here? And you need a certificate on the Radius computer, on the IAS server. But you don't need client certs if you're going to do protected EAP with MD5 or MSChat v2. We are backporting this to Windows 2000. If you go look at 313.664, you'll see how to do that. You need Service Pack 3 on the client and on the IAS server. We're not backporting the wireless 0 configuration to the client. So you'll still need to use the NIX software to configure the SSID and stuff like that. And in Windows 2000, we are supporting only TLS and MSChat v2. Now you think, well, but that's all you're doing in Windows XP. Well, XP and Windows Server 2003 will have additional protected EAP methods added to them later. We probably will not be backporting any of those to Windows 2000. I should say that if you decide to deploy a Windows Server 2003 Radius server, you do not need a Windows Server 2003 domain for this. It can be a member of a Windows 2000 domain just fine. That's what one of my customers has done, and it works. So how do you set it up? There you go, 9 easy steps. And literally, I mean, it took me 20 minutes in a lab, and I had never seen this before. It's pretty simple. So you build your IAS server, you join it to the domain. After all, it's got to talk to the domain controller, right? So the authentication server must belong to the domain. Enroll it for a computer certificate. Register the server in Active Directory, and that means you right-click on the server name in the IAS UI and say what? Register in Active Directory. Don't you love GUIs? Really, what does that mean? There is there's a security group in a domain controller called RAS and IAS servers. this security group is allowed to read certain user attributes in the directory. So when you add the IAS server to this group, the server can read these user attributes, which is necessary. Be sure to configure radius logging. You can log it to a text file. I prefer to send it to a SQL server. Add the access point as a radius client in the IAS configuration. Then you telnet or HTTP over to the access point and configure that thing for radius and 802.1x. So this means your AP, like I said at the beginning, needs to know how to do 802.1x. Create a wireless client access policy. Ooh, what's an access policy? How many of you have actually installed the radius server, the IAS in Windows Server? A few of you, OK. So those of you who haven't seen this, our IAS server has a policy engine in it. And the policy engine allows you to set parameters under which clients can be accepted for authentication or not. So, certain times of day, whether the user account belongs to a certain Windows group. There's a variety of things that you can set. So in the help, actually, it tells you what you want to set for a wireless client access policy. You have to have some policy. Without a policy, the IAS server won't authenticate anything. But you could use this IAS for more than just wireless, right? You might use it for VPN too. So you might want to have a different policy for VPNs. It's OK. And then finally, you need to configure the clients. Now, one thing that's important, remember that the radius server is passing its certificate through the AP to the client. The client is going to validate the chain. So whatever CA signed that certificate from the server needs to be in, that CA's public certificate needs to be in the client's intermediate or root stores. So the easiest way to make that happen, right, is if it's a Windows 2000 CA and you've turned on auto-enrollment for computer certificates. Because now the client computer will have a computer certificate, even though it's not being used if you're using password authentication. An advantage of auto-enrolling clients for computer certificates is that it puts your own CA's public key or public certificate in the client store at boot time, if it's not already there, right? It's kind of a cool thing. That way you don't have to have people go to some URL and download it. Come on, button. Click. What should that policy look like? It's actually a pretty simple access policy. Set the NAS port type value to that wireless IE EE 802.11 and wireless other. I'm not exactly sure why you need wireless other. I know that if you omit wireless other, it doesn't work. And I haven't been able to get an answer why. So it's one of these things that, somebody way deep down in the organization knows the answer to, and they keep them pretty well hidden. Set the Windows group to some group in Active Directory. Maybe you don't want it. Maybe you don't need to use this if you're going to allow all your users to do wireless, right? But if you're going to subset the number of people who can do wireless in your organization, then stick them and their computer account, don't forget that, into this group that you create. Also, part of creating a policy is configuring a thing called a profile that lives on the policy. On the profile itself, you want to disable all regular authentication methods. So, we're not doing MSChap v1 or MSChap v2 or PAP, right? Or any of these things natively over the wire, right? We want to do them only in EAP, and furthermore, only in protected EAP. Now, when you're configuring this policy on the Radius server and you say you want to use EAP or protected EAP, a dialog will appear and it will say, oh, what certificate should I use when I'm authenticating myself to the client? Well, you're going to use the certificate from step 3 on that previous slide. Configure only the strongest encryption, please. And then you're actually going to set this other value here, ignore user dial-in properties, to true. On an Active Directory account is is an attribute that can be set to true or false or check policy. And this attribute is simply followed by any kind of remote authentication mechanism, right? So if you're VPNing into a network and you type in some credentials and the RAS server goes to AD and it says, hey, is this guy allowed to log in? One of the things it looks at is this value, dial-in user attribute. If it's set to true, the user is allowed in, and the policy is not evaluated. This is a value on the account, remember. If the attribute value is set to false, the user is disconnected. If the attribute value is set to follow policy, then Radius or RAS will follow the policy. You know, are we in the right group? All these kinds of things, right? We want to set ignore user dial-in properties to true in this case to force policy evaluation at all times for wireless users. Because you want to make sure that you're using protected EAP only and that you're using 128-bit encryption only. So what else? Interoperability might be a concern for some of you. We have not written PEEP in a vacuum. We've worked with Cisco and RSA to develop PEEP. As usually happens, there's a couple different versions of this thing. We have implemented version 0, and it is not compatible with version 1. So we're getting back together again, and we're saying, OK, we're going to be adults about this now. And we're going to come up with a new version of PEEP, probably called version 2, that will interoperate and play nice with everybody. What about alternatives to 802.1x? This is the thing I couldn't remember at the beginning, this WPA, Wi-Fi Protected Access. WPA includes a protocol that Cisco has written called Temporal Key Integrity Protection. So this uses RC4, just like WEP does. Oops. And rather than generating a new key after a time interval or when someone roams to a new access point, WPA rotates keys every 10,000 packets. We combine that shared 128-bit key, the one that's in the access point. Remember, the AP still has a WEP key. We combine that with the client MAC address and a much larger initialization vector to provide key uniqueness for each client. So WPA still uses 802.1x for user and mutual device authentication, but it has its own key handling mechanism. And we actually are beta testing this now for Windows XP. And I think just like last week, the beta got closed, which means we're probably pretty close to releasing this to the web. So you now have a choice. You can use 802.1x or you can use WPA. But WPA is just temporary. The long-term future is 802.11i. WPA still doesn't fix the two problems that we've had earlier, right? That packet spoofing or the disassociation. 802.11i includes TKIP, 802.1x, and the notion of a keyed IC. It uses AES now instead of RC4, and it addresses all of the known vulnerabilities in WEP plus the two that we can't fix with 802.11 or 802.1x or WPA. You need to belong to the IEEE if you want to read up on this. It's not a free standard downloadable. And the last time I checked, they're expecting ratification this September. So it's not that far away. And IEEE tends to be pretty good on their predictions. So here's a slide here where you can read some more about some of these technologies if you want. And that's all I have. So I want to thank you very much for coming. And I'll stay up here if you guys have any questions. Thanks for coming to the conference. It was great getting to know all of you. Bye.